Welcome back. Today we are going to discuss about an interesting problem that could be solved by a popular algorithm strategy, recursion. Hope you know the meaning of recursion. Recursive algorithms are the algorithms that call itself. So they could be classified as direct recursive and indirect recursive. By direct recursive, the call to the function will appear in the body of the original procedure itself. Say function A is a recursive algorithm, so then call to function A will appear in the body of the function A. Indirect recursive means function A calls function B and function B will have a call to function A. So it's indirect recursion. Somehow function A calls itself. So a function that calls itself is defined as a recursive function. There are so many problems based on recursion. Finding the factorial of a given number is a good example for recursion. The most famous problem that is solved using recursion is Towers of Hanoi problem. Today we are going to discuss about the recursive implementation of Towers of Hanoi. So what is Towers of Hanoi problem? So Towers of Hanoi is a mathematical puzzle, we can say, or indeed it's a myth. It was told that in ancient days there were 3 towers having very heavy discs. The 3 towers. The first tower has n number of heavy discs. So the priest wanted to move those heavy discs from one tower to the other tower. So there are 3 towers, right? So they wanted to move the first disc from the first tower to the last tower using the intermediate tower. So you cannot move more than one disc at a time, and at any time you cannot place a bigger disc over a smaller disc. So these are the constraints for moving the discs from one tower to the other tower. So this problem has been transformed into a mathematical puzzle, and that is solved using recursive algorithm. So what are the simple rules? Only one disk can be moved at a time. During each move, we cannot place a bigger disk over the smaller disk. The 2 important conditions are only one disk can be moved at a time and no disk may be placed on top of a smaller disk. So satisfying these constraints, we need to move n disk from the source tower to the destination tower using an intermediate tower. Let us see how it can be implemented using recursive algorithm. First, let us see how it can consider there are 3 disks. Right? So we want to move the 3 disks from tower A to C using B as the intermediate tower. These are the possible ways. First, you move the smallest disk from tower A to tower C. Second move is move the second smaller disk from A to B. Third move is move the first disk from C to B. Now we moved only one disk at a time, and we have moved n-1 disk from A to B. Now we are free to move the largest disk from the source tower A to the destination tower C. So the next move will be moving the first disk from A to C. Right? So we have completed half of the task. We have moved the largest disk from the source tower A to destination tower C. Now the next task is you need to move the disk from tower B to C. So totally there are 3 disks. Now we have moved n minus 1 disk, that is 2 disks from the source tower to the intermediate tower, and then we have moved the largest disk from the source tower to the destination tower. So the challenge here is we need to move again these 2 disks from tower B to tower C. So here as tower A is empty, we can use it as the intermediate tower. So the smallest disk from tower B will be moved to A. So the next move will be that. The smallest disk in tower B will be moved to A, and then the second disk will be moved from B to C, and finally the smallest disk from tower A to C. So we have achieved our task. We have moved all the 3 disks from the source tower A to destination tower C, following the constraints. So if you observe this problem, you could see that it is recursive in nature. In order to move n disk from the source tower to the destination tower, we first moved n minus 1 disk from source to intermediate tower. Hope you understand. So in order to move 3 disks from the source, from say in this example from A to C, we first move 2 disks from A to B. And then after moving the largest disk from A to C, we again moved the 2 disks from B to C. So the problem is moving n disk involves moving n minus 1 disk from source to intermediate tower and from intermediate tower to the destination. So as the problem is recursive in nature, we can devise a recursive algorithm for solving it. So in this case, the Python code, if n is equal to 1, it's simple, move the disk from source to destination. Otherwise, we need to move n minus 1 disk. So the first call is Tawasa-Fanai. We are calling the same function. So this is the feature of recursive function. So Tawasa-Fanai is a recursive function. It is called in its own body. So Tawasa-Fanai with different parameters. Here n minus 1 disk from the source auxiliary. So we need to move from the source to the auxiliary tower using destination as the intermediate one, and then move the largest disk from the source to the destination, and then again move the n minus 1 disk from the intermediate tower to the destination using source as the intermediate tower. So this is how Tawasa-Fanai solved. So it's a good example for recursion. As you notice, you could see the call to Tawasa-Fanai appears twice within the body of the function. So the same function is called within the body of the function. We call this as recursive implementation for solving Tawasa-Fanai problem. Hope you understand. So the output would be move disk 1 from source A to destination B, and then move disk 2 from source A to destination C, and then again move disk 1 from source B to destination C, and then move disk 3 from source to destination B. Here we assume B is the destination, and then C is the intermediate. So we have moved 2 disks from A to C, and then move disk 3 from source to destination from A to B, and then the last 3 steps we will be moving n minus 1 disk from the intermediate C to the destination B. So this is a simple version of implementation of Tawasa-Fanai problem. So to summarize, so we discussed Tawasa-Fanai problem. We solved it using recursive algorithms. Recursive algorithms are algorithms that call itself. We have 2 types of recursive algorithms: direct recursive and indirect recursive. Direct recursive algorithms, the function call will appear in the body of the function itself, In indirect recursive, it will be called indirectly. That is, a recursive function will call another function, and the second function will call the parent function. So indirect recursive. We discussed an example for recursion, the towers of Hanoi, where n disks have to be moved from the source tower to the destination tower using an intermediate tower satisfying two conditions. There is only one disk can be moved at a time, and at any time bigger disk cannot be placed over a smaller disk. So we discussed the Python implementation of the algorithm. If you trace the algorithm, you will understand very well. So thank you for listening. We will discuss the remaining topics in the next session. Thank you.